Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. Today's problem is on finding the diameter of a binary tree. Let's jump into the problem and start solving. So we have reached 21st problem as of today. Okay, last time we have solved add binary tree, we already marked it tick. Let's start solving diameter of binary tree. Let's go through the problem statement quickly. Given the root of a binary tree, return the length of the diameter of the tree. Now, the diameter of a binary tree is the length of the longest path between any two nodes in a tree. The path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. Okay, so we know that diameter is the longest path plus length is calculated based on the number of edges that exist in the path. We can see in this binary tree the longest path is 4, 2, 1, 3. If we calculate the edges, one edge here, one edge here, and one edge here. So total 3 edges. So diameter is 3. We can see diameter is 3. Similarly, we could have also taken 5, 2, 1, 3, and the length would be one edge between 2 and 5, one between 2 and 1, and then 1 and 3. 1, 2, 3. 3 edges. So we could have taken any one of them and we would have arrived as the maximum length or the diameter as 3. So it doesn't matter to us which one we choose, because we are not bothered by the numbers. We only need to find the diameter. Now, in order to find the diameter, it is a pretty straightforward problem. If you understand the DFS and binary search tree by now, all we have to do is we have to find out the depth of each left subtree and the right subtree, and we have to find out what is the current maximum diameter. Finding the depth of each of the subtrees, and then the same we have to do it recursively. Okay, let's go through the code and understand it from the code. Okay, let's initialize diameter, int diameter that we have to return, diameter equal to 0. Okay, since we want to call the function recursively, we can use this function, or let's create another function that we will be calling recursively. Okay, we'll call it private int calculate diameter. We'll pass tree node. Let's call this node. Okay, from here we can simply call or we could have actually say int diameter is equal to calculate diameter and pass root, right? Then return diameter. Okay, now this is the function which will be responsible for calculating the diameter, plus this will be the function we'll be calling recursively for each node to find out the depth of left subtree and the right subtree, right? In end we have to let's say if I am at 2, okay, I find out the depth of left subtree, which is 1. I find out the depth of right subtree, which is 1. Maximum of the 2 is 1, right? So my maximum depth would be 1 for this, 1 for this. But now I can go from 4 to 5. So I'll add 1 for this current node, and the maximum length for the diameter will become 2, right? That's why it's required that we find out the maximum depth of the left subtree and the right subtree. Okay, now when we are calculating the diameter, we have few base conditions. We'll put base condition, which would be if node is null, diameter is 0. Okay, so we can simply say if node is equal to null, return 0. Now let's calculate the depth of the left and right subtree, right, as we discussed. So we'll say int left depth is equal to, we'll call the same function recursively, calculate diameter, and we'll pass node dot left. Similarly, we'll call it for the right side, int right depth is equal to calculate diameter and pass node dot right. Simple, right? So let's imagine the tree was only 4 to 5. We are at 2. We want to find out the depth of 4, the left subtree, depth of 5, the right subtree, and then we'll figure out the overall diameter. Okay. Once we have the depth from each side, each left subtree and the right subtree, okay, because for finding out the depth we are calling this function recursively, we'll update the diameter. So we'll say update the diameter. Now what will be the diameter? So diameter would be the maximum diameter found so far. Okay, it would either be the left depth plus the right depth or the maximum diameter that we already have, because it is not required, as they say, this path may or may not pass through the root. So if the left depth and the right depth addition is more than our current diameter, we'll ignore our current node. Okay, so update the diameter with the maximum diameter found so far. Okay, so we'll say diameter is equal to math.max of either the original diameter that we have found as of now or left depth plus right depth. That's it. Now, but this is not the overall diameter as of now. Okay, we are still required to return the maximum length that we'll calculate from this function. Okay, now what is that one part which is missing right now? Let me comment and we can understand it. Okay, so we'll say return the depth of the current subtree. Okay, what is that maximum depth of a current subtree? This maximum depth would be a maximum depth of left subtree or the right subtree plus 1 for the current node, right? So we can say it would be max of depth of left or right subtree plus 1 for the current node. Okay, so we can say now return math dot max of left depth or right depth plus 1. Okay, so when we are at 2, the maximum depth of 4 is 0, maximum depth of 5 is 0. We'll find out the maximum of these two, which is 0. We'll add 1 for this node because this one node gives us this edge, and that becomes the maximum diameter for this single path. Similarly, this approach is taken forward. Now we have 1 maximum depth from this part of subtree. Similarly, from this part of subtree we'll get 0. We'll give 1 extra to this one for reaching 1. We get 1 here. Now this one will achieve one more 1 from this path, and we'll get 2 from the left side, 1 from the right side. And then we add the left diameter, which is 2, and the right diameter, which is 1. Left diameter plus right diameter. So 2 plus 1, 3. Is this bigger than our diameter found so far? Yes, because last found diameter would be here, which was 2. So we'll change it to 3 and the answer will get updated. Okay, let's run it. So it may seem a little complicated, but the solution is really easy. Give me 1 second. Somewhere we are facing an error. Diameter. Why this is not okay? I want to calculate the diameter here, but I want to provide it again. I've defined it locally. Okay, I'll do it this way. We'll say int diameter, we'll make it public, equal to 0, and here should I return anything, or here I can say diameter. Okay, let's see. Okay, wrong answer. Somewhere something is failing. Expected output was 2 and we are getting 1. This has happened for this one, the second test case. Somewhere our code is not working fine. Let's check. We initialize the diameter. In diameter we'll say public in diameter of binary tree. We'll try to find, this was already given, we have the root. We created a function for calculating the diameter, provided the return type with int node. If node is equal to null, will return 0. Otherwise left depth will be calculate diameter again, node dot left. Right depth would be calculated diameter, function called again, node dot right. Diameter would be maximum of either the current diameter that we have or the summation of left depth and right depth. This is also okay. Then we are going to return max of left depth or right depth and then add 1 for the current node. That is also correct. Okay, I'll not initialize this diameter here. I'll directly return this one, and we are only calling this function once. This will get completed and this will be updating the diameter value directly and will be returning the diameter value from here. Because when I was calling from here, it was updating the new diameter value from the first call, and we want to return the final call. Let's run it and check. Okay, it's working. Let's submit. Okay, great. So solution is efficient. Please go through this video with bit of care, because the problem is simple, solution is simple, but slightly complicated. If in case you face any issues in understanding this problem statement or the solution, please let me know in the comment section and I'll be happy to engage with everyone. Okay, that's all from today's video, everyone. Thank you very much. Please like, share and subscribe.